In this lesson, you'll learn about the addition rule. The addition rule says that if two events A and B are mutually exclusive, meaning they can't happen at the same time, then the probability that either A or B will occur is the sum of their probabilities. In other words, the probability of A or B happening is the same as the probability of A happening plus the probability of B happening. Let's take a look at a few problems and see how this works. When reaching into a bag of marbles and randomly selecting a marble, the probability of getting a red marble from the bag is 5 out of 12, or 5/12, and the probability of getting a green marble is 1/8. What is the probability of getting a red or a green marble? First, we have to decide if this is a mutually exclusive event, meaning is it possible to put my hand in the bag and pull one marble out and get a red and a green marble at the same time? And I can't do that. I'm going to get a red marble or I'm going to get a green marble. So they are mutually exclusive. And what that tells us is that we can use the addition rule. So the probability of getting a red or green marble is going to equal the probability of getting a red marble plus the probability of getting a green marble. That's going to give us 5/12 plus 1/8. And we need a common denominator, of course. A common denominator for 12 and 8 is going to be 24. And to change 5/12 into a number over 24 and keep it equal, we would have to multiply the top and bottom by 2. That's going to give us 10/24. And now let's look at the second one. 8 goes into 24 3 times, so we have to multiply the numerator by 3 also. And that gives us 3/24. Now we have a common denominator we can simply add. That gives us 13/24. So the answer to this question is the probability of selecting a red or green marble from the bag is going to be 13/24. Now let's take a look at another question. Students were divided into 3 groups and given 3 jars of marbles. They were asked as a group to go to the board and record the probability of getting a red marble out of their jar, the probability of getting a blue marble, and the probability of getting a green marble. There were other colored marbles, but they were just to focus on red, blue, and green. The results from 3 groups' jars are recorded here on this board. Then they were asked, from which jar is the probability of getting a blue marble or a green marble the highest? So let's see if we can answer that question. Let's look at the first jar. So for the first jar, the probability of getting a blue or green marble is going to be the probability of getting the blue marble, which is 2/17, plus the probability of getting the green marble, which is 3/17. When we add those together, we already have a common denominator. That gives us 5/17. Now let's look at the second jar. For the second jar, the probability of getting a blue marble is 1 out of 15, and the probability of getting a green marble is 1/3. So we do need a common denominator here. It looks like 15 is our lowest common denominator, so we'll leave 1/15, and then we'll change 1/3 to something over 15. 3 goes into 15 5 times, so we're going to multiply the top by 5 also, and that gives us 5/15. Now we can add and we get 6/15. Let's go ahead and reduce this. 3 is a common factor for both the numerator and denominator. It goes into 6 twice, and it goes into 15 5 times. Now let's look at jar 3. The probability of getting a blue marble from jar 3 is going to be 1/4, and the probability of getting a green marble is going to be 1/6. The least common denominator for a 4 and a 6 is going to be 12. To change 1/4 to something over 12, we're going to multiply the top and bottom by 3. And to change 1/6 to something over 12, we're multiplying the top and bottom by 2. When we add this, we get 5/12. Now the question is asking from which jar is the probability of getting a blue or green marble the highest. So we have to do a comparison here. We're going to compare 5/17, 2/5, and 5/12. I think we can easily eliminate from 5/17 and 5/12 the 5/17. 5 pieces out of 12 is going to be bigger than dividing something into 17 pieces and taking 5. That leaves us with comparing 2/5 and 5/12. Now those are probably pretty close, and we can tell that because 2 is close to half of 5 and 5 is close to half of 12. So how about if we come up here and write out 5/12 and 2/5 and get a common denominator for 5 and 12. A quick easy way to do that is just multiply 5 and 12 to get 60. since we multiplied 12 times 5 to get 60, we can multiply 5 times 5 to get 25. And since we multiplied this 5 times 12 to get 60, we can multiply 2 times 12 to get 24. Now we can see with this common denominator that 25 sixtieths is more than 24 sixtieths, but it's really close. There's only a difference of 1 60th. This tells us that 5 twelfths is the bigger number. So the answer to this question, from which jar is the probability of getting a blue or green the highest, is going to be jar 3. Now let's take a look at another problem that's a little bit different. In this question, instead of being asked for the probability of A or B happening, we're given that probability. That's going to be 2/3, and we're being asked to find the probability of B happening. This is a pretty straightforward question. We know that if A and B are mutually exclusive events, and in this question we're going to assume they are, then the probability of A or B happening is going to equal the probability of A happening plus the probability of B happening. Now let's fill in the numbers that we have. We have the probability of A or B happening is 2/3, and the probability of A happening is 14/75. The only thing that's missing is the probability of B, and I'm going to use the variable x here. So this is a linear equation with one variable. We can solve this. We'll subtract 14/75 from both sides, and to do that we're going to need a common denominator. 75 is a multiple for both 3 and 75, so we'll use that as our least common denominator. 3 goes into 75 25 times, and 2 25s are 50. 14/75 doesn't need to be changed, so we'll leave that the same. Now we have 50 minus 14, which is 36 over our common denominator of 75. We should check and see if that can be reduced. 36 is divisible by 3, which gives 12, and 75 is divisible by 3, which gives 25. The probability of event B occurring is going to be 12/25. This time, two groups in the class were given jars of marbles, and they were asked to calculate the probability of getting a red or blue marble from their jars and record it on the board, and then calculate the probability of getting a red marble or a blue marble, but not both, and record those values as well. And the rest of the class was asked to fill in the blanks here and here. Let's see if we can figure out what should go in these blank spots. Let's look at the first jar. The probability of getting a red or blue marble is 8/11, and we know that should equal the probability of getting a red marble plus the probability of getting a blue marble. And I'm going to use the variable B here for blue marble. So all we need to do is subtract 3/11 from both sides, which gives 8/11 minus 3/11 equals B, and then evaluate. 8 minus 3 is 5 over 11 equals B. So in our first space here, for the probability of getting a blue marble in jar 1, we should have a 5/11. Now let's do jar 2. For the second jar, we have the probability of getting a red or blue marble is 11/24. And we know that should equal the probability of getting a red, which I'm going to use the variable R here, plus the probability of getting a blue, so plus 1/8. So let's subtract 1/8 from both sides. That'll give us 11/24 minus 1/8 equals R. We need a common denominator, and the least common multiple for 8 and 24 is going to be 24. We'll leave 11/24 the same and change 1/8 to 3/24. 11 minus 3 is 8/24, and we should reduce our 8/24 to 1/3. So the probability of getting a red marble from jar 2 is 1/3. Now you know a bit more about the addition rule and how to use it. See you next time.